Introduction of the system. A hydroelectric power plant is a renewable energy source that generates electricity by using the power of running water. It works by harnessing the kinetic energy of falling water, which is then transformed into the mechanical energy and finally into electrical energy. Hydroelectric power plants are typically located near dam or river with high water flow and are widely used to provide electricity to homes and businesses around the world. The universe follows the conservation of the energy principle. Therefore, if we extract electrical energy from hydroelectric power plant, then it means that some source is there to feed the energy into the cycle to keep it running. That source of energy is sun in the hydrologic cycle, also called water cycle. Evaporation takes place above the large water bodies such as oceans. The vapor rise and form clouds which are driven through wind. Once the cloud reach area of higher altitude and lower temperature, waterfall in the form of rain, the water is collected in a large water reservoirs having higher altitude than sea level. This water heat can be used to generate electrical energy out of it. Nonetheless, the water complete the cycle after eventually becoming part of the ocean. The cycle repeats. How exactly is electricity generated at hydropower plant? Because hydropower use water to generate electricity, plants are usually located on or near a water source. The energy available from the moving water depends on both the volume of the water flow and the change in evolution, also known as the heat from one point to another point. The greater the flow and the higher the heat, the more electricity that can be generated. At the plant level, water flow through a pipe, also known as a penstock, and the spin the blade in a turbine, which in turn spin a generator that ultimately produce electricity. Most conventional hydroelectric facility operate this way, including run of the river system and the pump storage system.
The main component in hydroelectric. The first one is a forbe. A forbe is a basin area of hydro power plant where water is temporarily stored before going into the intake chamber. Number two is intake structure. Intake structure is a structure which collect the water from the forbe and direct it into the penstocks. Number three is penstock are like pipe lid with some slope which carry water from inside a receiver to the turbine. Number four is surge chamber. It's a cylindrical tank which is open the top to control the pressure in penstock.
Now, I will continue about what Najmi explained earlier. And the next one, number 5, hydraulic turbine. Hydraulic turbine, a device which can convert the hydraulic energy into the mechanical energy, which again convert into the electrical energy by coupling the shaft of turbine to the generator. The mechanism in this case is whenever the water coming from penstock strike The circular blades or runner with high pressure, it will rotate the shaft, provide at the center, and it cause generator to produce electrical power. Number 6, powerhouse. Powerhouse is a building provided to protect the hydraulic and electrical equipment. Generally, the whole equipment is supported by the foundation or substructure laid for the powerhouse. In case of reaction turbines, some machines like draft tubes, scroll casing are fixed within the foundation while laying it. So, the foundation is laid in big dimensions. Number 7, draft tube. If reaction turbine are used, then draft tube is a necessary component which connects turbine's outlet to the tail race. The draft tube contains gradually increasing diameter so that the water discharge into the tail race with safe velocity. At the end of draft tube, outlet gates are provided which can be closed during repair works. And the last one, tail race. Tail race is the flow of water from turbine to the stream. It is good if the powerhouse is located nearer to the stream, but if it is located far away from the stream, then it is necessary to build a channel for carrying water into the stream. Otherwise, the water flow may damage the plant in many ways, like lowering turbine efficiency, cavitation, damage to turbine blades.
How a hydroelectric power plant. Basically, a modern hydropower plant is comprised of a receiver, a dam, penstock, turbine, and generator. The receiver stores the fuel and allows operator to control how much water is fed to the turbine. It also serves a descenter. Most of the dirt and debris in the water settle at its bottom and away from the intake area. Water from the receiver is delivered to the turbine through the intake dam gate and penstock. A filtering system at the intake further cleans up the water to ensure that it is relatively free of suspended solid, which could damage the turbine blade. Hydraulic system. The governor, the brake, the gate control, and so on work together to open and close the aperture that allow water to flow downstream from the receiver. The water wheel of the past have evolved into the modern turbine, differing mainly in their blade shape and configuration. The three main types are franchise turbine, the Kaplan turbine, and the Pelton turbine, named after their inventors. Regardless of design, the turbine converts the kinetic energy of moving or falling water into mechanical energy. The turbine is connected through the shaft to the rotor of a generator that converts the mechanical energy into electricity. For the greatest efficiency, turbines are custom-made for each hydroelectric plant, while the concept of hydropower are simple and straightforward. The operations are anything but each modern hydroelectric power plant relies on a multitude of complex systems that monitor, control, and improve conditions to ensure proper operation. Bearings and lubricating systems minimize friction and wear and tear in moving parts. Filters trap the particulate that can abrade turbine blades. Powerful hydraulic system open and close the penstock gate. Cooling system keep temperature under control to prevent overheating and fire in transformers, cable, switchgear, and other electrical and mechanical mechanisms.